This presentation provides an introduction to machine learning systems, with a focus on MLOps and production machine learning. This is about building scalable and reliable machine learning solutions. MLOps combines machine learning development with operations to automate and streamline the machine learning lifecycle. MLOps is the combination of machine learning and DevOps. Machine learning includes model development and training, and DevOps includes automation and deployment. The machine learning lifecycle consists of 4 key phases. First, the data phase involves collection and processing of data. Second, the model phase, which includes training and validation. Third, the deploy phase, which focuses on production release. Fourth, the monitor phase, which is about performance tracking. A typical data pipeline architecture consists of 3 stages. First, the extract stage involves extracting raw data from various sources. Second, the transform stage includes cleaning and processing the extracted data. Third, the load stage focuses on loading the transformed data into a feature store. Here's an example of an extract, transform, load pipeline using pandas. We start by importing pandas. The extract data function reads data from a CSV file. The transform data function cleans the data by removing rows with missing values and resetting the index. The load data function saves the transformed data into a Parquet file. Model training and versioning is a crucial part of the machine learning lifecycle. As models evolve, it's important to keep track of different versions. Here is a version tree. We start with version 1.0, the initial model. Then we move to version 1.1 with feature updates. Finally, we have version 2.0, which is production ready. Here's an example of a model training pipeline using MLflow. First, we import MLflow. Then, within the MLflow start run block, we train the model with xtrain and ytrain. We log the accuracy metric, and finally we save the model using MLflow sklearn log model. Continuous integration and continuous delivery are essential practices in machine learning. The CI pipeline involves testing and validating the model. The CD pipeline includes deploying and monitoring the model. Here's an example of a GitHub Actions workflow for a machine learning pipeline. On every push, the test job runs on an Ubuntu latest runner and executes the testmodel.py script. There are various strategies for deploying machine learning models. The real-time API deployment, which offers low latency predictions. Another is the batch processing deployment that provides high throughput jobs. Here's an example of a fast API deployment. We start by importing fast API. We create an instance of fast API called app. We define a predict endpoint using the app.post decorator. The predict function takes data as input, makes a prediction using the model, and returns the result. Model monitoring and observability are important for maintaining model performance in production. We need to track performance metrics such as accuracy and latency. Also, it's important to monitor data drift. Here's an example of model monitoring using Evidently. We start by importing Evidently. We create a report with the data drift preset. We run the report with reference data and current data, and save the report as an HTML file. There are numerous tools and technologies available for MLOps. For experiment tracking, we have MLflow, Weights and Biases, and Neptune. For orchestration, we can use Kubeflow, Apache Airflow, and Prefect. For deployment, we have Docker, Kubernetes, and AWS SageMaker. Here are some of the best practices for implementing MLOps. Automate everything, monitor continuously, test rigorously, and document everything. The key takeaway is that MLOps bridges the gap between machine learning experimentation and production deployment. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.